All right. One of the things that I think Switzerland has done to me is being on time. And so I think it's 3:01, so I reckon we'll start. Um, there's enough people joining in as well. So thanks everyone for joining. So officially kicking it off. First, Sam, thanks for making time. I really appreciate, especially from early stage founders, making time. I know that you've got a ton of stuff to do, but taking time to talk to us really means a lot. So thank you. And and also would like to introduce Hafida, who's part of the entrepreneurship team. She joined 1st of May, and in about 3 weeks, she's done so much that I'm super excited to have you on the team. So welcome. My name is Ash Ravi Kumar. I take care of the entrepreneurship activities for CERN. I'm part of the knowledge transfer group. So if you're a startup, you're looking at some technology that CERN can help, please reach out to us. And if you're a founder from CERN thinking about doing a startup, please do reach out to us. We're here to help in any way we can. So with that, Sam, today I just want to have a talk with you, chat with you also about how you started from the lab, how you went to your startup. But before that, I'll just go do a quick run sheet and a couple of housekeeping. This is recorded, so if anybody has an issue of being on recorded, please let us know, and we will record it and post it online. I don't know how we edit some of the stuff, but if there's really an issue, please do let us know. Chats and questions, please use the Q&A box. Q&A preferred, but some people write it in chat as well. We'll keep it open and we'll ask the questions at the end of the talk. Run sheet, Sam's going to present about DePoly first, and then we'll have a chat for about 20 minutes, and then we'll go to question and answers. With that done, Sam, floor is yours. You can stop when you are ready.
Perfect. So I'm just going to share my screen. Just if you guys can confirm that you can see it.
Yes, all good.
Perfect. So yeah, thank you so much for the invitation to speak about the company and the journey and everything. I'm Samantha Anderson. I'm the CEO and one of the co-founders of DePoly. And we are a spin-off that came out of the EPFL Valet chemistry department, essentially. This was a project that started as kind of a side project to my actual PhD, and then it started gaining speed and momentum, and then we were able to make a company out of it. So what we're doing is we're tackling the plastic problem. For anybody who's not familiar with what's happening right now, of the 56 million tons of PET plastic that we produce yearly, only 9% is actually recycled. And this is because essentially anything that gets recycled has to be perfect. So if you, for example, if you have a bottle or a shirt or a container or anything that's dirty or it's mixed plastic, this can't be recycled. And depending on where you live in the world, this either gets incinerated if you're in Europe, or if you're in North America, it typically just gets thrown into a landfill. And in some cases, it gets shipped from North America to Asia. Along the way, it gets dumped into the ocean. And then we have plastic patches the size of Texas that are roaming around and disturbing marine life. So this is a huge problem. It's a huge global issue. And so we decided to tackle it. And we did this using chemical recycling. And so what we do is it's a room temperature method. We don't use heat, we don't use pressure, and we can take anything that has PET plastic in it and convert it back to the two main monomers that make up PET plastic. These are referred to as terephthalic acid, TPA, and ethylene glycol, EG. If you're looking at it on a market perspective, they're typically labeled as PTA, as purified terephthalic acid, and MEG for monoethylene glycol. But what we do is we essentially take the PET plastic and then cut it at its bonds through a hydrolysis method to make these two monomers, and it comes out at the exact same quality as the same stuff we get from petrol. So right now, all of our plastic is sourced from petrol, and we're able to produce the exact same components from our post-consumer waste. Because the whole process operates at room temperature, we can save money on our energy recycling bill. And because we make the same monomers as the petrol industry, we can indirectly reduce the amount of CO2 that we produce by just using our garbage. Overall, we can also treat anything that has PET plastic in it, with the exception of nuclear waste and biohazardous, which is just something we haven't been physically able to get our hands on. So we can do shirts, clothing, shoes, hats, bottles, containers. They don't need to be sorted. They don't need to be separated. They don't need to be pre-washed. So we don't worry about colors or anything like this. And this also saves then people a lot of time, money, and resources to do the actual recycling process. The monomers, after they're produced, we sell back to industry, and industry can basically do what they want with it. This can be, for example, to make new virgin PET plastic or fibers or whatever, but you can also think of selling it back to chemical industry like Sigma Aldrich or Merck, who would supply this to academic labs or pharmaceutical companies. So our value chain is kind of straightforward. We act essentially as a bridge between the users of PET plastic and the makers of it. So for example, right now we work at a central waste management plant in Ballet called UTO. And we take the plastic that we get there, we chemically recycle it, and then we sell it back to industry. And as I mentioned, industry can be the people who would make new virgin PET plastic resins or just make PET plastic resins, or it can be third-party suppliers. And what we offer and what we solve for our customers are a variety of problems that they face now, particularly around new laws that are coming out on the amount of recycled plastic that has to be in new virgin component plastic. So right now you can have like a 30% recycled, 70% virgin plastic bottle, but EU laws are only going to be increasing to make this essentially 100% recycled plastic. This is something I think a lot of people also commonly see on the side of water bottles. It'll say 100% recycled. So there's a lot of demand for the recycled material. And it's really hard to keep up with this demand because of the yield loss through the typical mechanical recycling methods that we currently use. And again, this is because they have to have perfect plastic to go into this process. So we can help these companies meet new EU laws or even any laws from other companies or countries out there. If you are a user of PET plastic that can't be recycled, you typically have to pay either for incineration or landfilling fees. Landfilling fees are a lot cheaper because it's just you dump it into the environment. But incineration fees aren't super cheap, especially if you're dealing on the hundreds of thousands of tons per year of potential waste that you can't use or it can't go back into your system. So we can help save money on that. We can save money on recycling because we can take the stuff that they can't deal with. So the dirty containers, the fabrics, the fibers, the mixed plastics. And also we can help reduce our reliance on oil. This is a huge social benefit that our customers or clients can pass along to their customers and clients. So for example, if you go and buy a shirt from somewhere like H&M or Zara and it says 100% recycled, you would know that this shirt didn't come from an oil process, and it might help people make more informed or smart choices when they buy new textiles, for example. And yeah, so there's a wide variety of issues that we can help solve for them. The team itself is myself, Chris, and Bardia. We're the co-founders. We started the company and the project during our PhD/postdoc. So for PhDs, it was myself and Bardia. Chris was the postdoc that was running the lab. We're currently expanding the team. So we have some chemical engineer, process engineers, and administrative people already who have joined. And we'll be hiring some chemists and more chemical engineers as well as process engineers, mechanical engineers, and these sort of things. Our board members are very strong in starting and supporting startups. So Wingman Ventures with Alex is fantastic for that. Anybody who's looking into a VC that is focused on like green tech, clean tech, as well as some other areas, they're really great. You should check them out. And we also have Chris McArdle, who's a former Dow DuPont member who currently works at Borealis. We also work a lot with industry. We try and focus on working with industry because they're the ones that have very specific standards that have to be met. So we have some Swiss companies that we work with, as well as some French ones like Armor. And we've had a lot of support in the Swiss ecosystem from people like Venture Labs, Climate Kick, and the ARC and Cleantech Alps, who have helped us basically get to where we currently are. And then just in comparison to other chemical recycling companies out there, and what really sets us apart is we actually operate at room temperature. So we don't say low temperature or anything like this. We don't use kind of like these popular keywords or key phrases that a lot of green tech might use. We also produce the two main monomers of PET. So Loop and Ionica produce different monomers. They can still be used to make PET plastic, but it's just a different component essentially. And we can use everything for PET plastic, not just bottles and fabrics. We're also going to be expanding relatively fast. But that's something that if anybody's interested, we can talk about and discuss in the Q&A portion. And so yeah, that's us in a very, very short presentation. If anybody's interested and they want to just chat after this, you're more than welcome to reach out to me. My email address is there, but I'm sure you guys can get in contact with Ash, for example, and have the information provided in case you miss it. So yeah, thank you.
Awesome, thank you. And if you can send me the presentation, I'll upload on Indigo as well, so people can look at the slide deck. Thank you, awesome. So first disclaimers, I reckon I am a chemistry naive, so I'm not going to ask any chemical questions. My sisters were biochemists, so in my house it was always paper with the hexagons everywhere. Fan of organic chemistry, so no chemistry questions from me. So for me, I really want to know about your journey, right? So first, how did a Canadian end up in Switzerland?
So I actually used to want to go into academia, and the longer I stayed in academia, so I decided that I didn't want to be there. It wasn't my place. So my husband and I were looking for new places that we could go that would have, for me, it was like industrially relevant topics that I could do. And so I ended up meeting up with my former professor, Professor Baron Smith, who does carbon capture and storage for adsorbent materials. So if anybody knows about metal organic frameworks, this is what my PhD was on. And so it was very lucky because he was moving from the US. And he needed to start a lab with somebody who had organic experience. And I was looking to get out of organic, and bridge into something new, but not lose that experience. So we were able to combine the two, and it worked out really well.
All right, okay. So you got the role, and then you moved from Canada to here. Okay, brilliant. So you did mention your PhD topic, or movement from it. How, and you said you wanted to get out of academia, and you still stayed on it. How did you choose this topic? How was the problem of what you were researching relevant to you to saying, yeah, this is a big enough problem, I want to spend more time on it?
So yeah, so during my PhD topic and the company were two different topics. So I started my PhD with the carbon capture and storage, making metal organic frameworks for new applications. And during my time, there was a lot of information that came out about plastic waste, and it was related to, for example, the articles where they had marine animals that were washing up on the beaches with stomachs full of plastic. But also there was some research papers that came out that just said how bad microplastics are and how they're now finding them in people. And so myself and my other two co-founders were discussing this topic, and we had said that we should try and use chemistry to solve it. Luckily enough, we all had different components of our backgrounds that matched really well for this, that we were able to use to take the chemistry to get it to where it is now. And Bardia is like a whiz at chemical engineering. He built our demo plant from essentially scratch. So yeah, we had very, very good complementary skills, very like the same interests, the same goals. We wanted to go to the same place with this. Yeah, so that's kind of how we went from PhD postdocs to that.
Okay, so I guess during that discussions with with the lab members of the lab, sure you stumbled on saying, this sounds interesting, and from there I think the thread went to, okay, let's put a little bit more effort into saying how feasible is this. How did that evolve from good, we can change this, to we're going to put more time into figuring out before the demo plant started being built?
Yeah, so once we got the chemistry working, so when we did the chemistry in the first place, we always had it in mind that if it was going to be scaled up, it had to be simple. We had to be careful of what solvents we used, because if you use a solvent that's explosive on a lab scale, if you grow that to a commercial size, then it just becomes even more explosive. Yeah, exactly. So you need to be aware of these things. So we started from the very start with that idea already in the back of our heads, and we tailored our solution to this. And once the chemistry was working, and once we had sat down and Bardia basically said this is exactly how we'd have to build it, we started taking it very seriously, and we wrote our business plan. The first thing we did was write a business plan, and we submitted it to Venture, which is a competition that's Swiss based, and we ended up winning it that year. So yeah, that was kind of the catalyst for us.
Awesome. So that was your first validation to saying, okay, let's write it up and throw it up and see what happens. And you won it and saying, other people think it's a good idea too.
Exactly.
Awesome. So one of the, if you see me looking this out, I've got my questions on the other screen. So what's interesting is for me is the team, the three of you, Chris and Buddy, are all from the same lab. And you all knew each other, you've worked with each other, and then to saying, okay, let's all three join hands and make this startup. How did that happen? What was the discussions behind it and saying, okay, we're all in? And how did the role definitions happen on who's going to do what?
So the role definition sort of happened, I think, naturally. Chris has had a lot of experience with the chemistry that we've done and that we will be using in the future. So I think it was natural for him to go into the CSO role, because that's kind of exactly what he's going to be doing in the future, is developing the technology and the chemistry for other plastics. Bardia, I think it speaks for itself. He knows how to build pilot plants, so Chief Technical Chief Technical Officer. And then I just took the CEO position. But I mean, when we make our decisions, we do it as a team. It's not one person is doing one thing more than the other one. If it's a discussion that's super important, we all sit down and we agree. The initial conversation was sort of just like, hey, if we get this to work, do you want to do a startup? And then it was like, yeah, if it works, we'll do it. Yeah. So it was a very easy, relaxed conversation.
I mean, I guess that's, looking for a co-founder to be that, because otherwise you're forcing a marriage. This way it's natural. It's like, yeah, if it works, let's do it.
Exactly.
So, and then, last part of before you start, then, you've got your PhD advisor, or, the lab professor who manages the lab, and he's on your advisory board. How did he react? When did you bring that up? Was it at the chemistry or when you applied to the venture competition? Because then do you have a hierarchy of the process, the machination? So I'm curious to know how that worked.
So from the very start, actually, even before we had nailed the chemistry down, we had talked to him about it, and just said, this is our idea. If it works, we want to make a startup, just to make sure that he was okay with it, because there would be a lot of work done in the lab that would be sort of outside of the frame of metal organic frameworks. So we were, very honest with him up front. He was very supportive, and he still is very supportive. So he acts as our scientific, basically advisor for questions that we have about this. It was again very easy, natural conversation to have. There's actually another startup that's going to be coming out of our group as well. That's more on the simulation side of metal organic frameworks. So if I'm not entirely sure the name, I can't remember it. I think it's MATLAB, or it's MATWorks, or MATChem. I have to double check that. But if anybody's interested, check out the LSMO group in EPFL Valet, and I'm sure Baron will be happy to point you in the direction of Daniele.
All right, awesome. So now you've got won the competition, and then what did you do next? How did you go about? Was the company that setting up the company came next, or was it something that you did before winning the competition and going, okay, we're going to incorporate the company?
No, we incorporated at sort of the last stage that we could. So we did the venture competition, and then we had also applied for the accelerator programs of Venture Kick and Climate Kick. And in the second stage of both of them, you have to incorporate. So we kind of waited until we had to incorporate to do this. Usually, depending on how you're doing the startup and on the business side of things, it's sometimes better to wait to do the incorporation later on. It just, you avoid some, I guess you have to start filling out VAT forms and things like this after the company is actually official. So you can kind of push that off as long as possibly can. So yeah, we waited to do it until we had to.
Okay. So the trigger to set the company up was because these accelerators said you need to be a legal entity to participate in the final sections of it. Okay, good.
Yeah. Yeah. I mean, we needed it to do it for our financing round, which was for like the end of last year is when we closed it, but we started it kind of mid, or I guess it was just before COVID. Yeah. So like March. or so. I'm getting my dates mixed up. Yeah, we did it. We had to do it anyways. We needed it to do it for our financing round because no one's gonna really give you serious money if you're not a real company. So yeah.
Yeah, so it's funny that I also remember things as pre-COVID and post-COVID right now. So totally understand with mixing up the dates. So one of the things you ran over fast was the painful paperwork that's required, right? So obviously, any chemistry somebody throws at you, you got it. Between the three of you, you've nailed it. But when it comes to business structures, business forms, of incorporating a legal entity, choosing business structure, SA, SARL. How did you guys go about it? What did you do?
So we ended up using a lawyer that the ARC had pointed us to, who kind of specialized in this to do the paperwork side of stuff, because I'm, as much as I've lived in Switzerland for almost 6 years now, I don't know the legal side of stuff as in detail as somebody like a lawyer would. So we got help, like professional help for it. And that was thanks to Eric Plum from the ARC Clean Tech Alps.
Mm-hmm.
And for us, we decided to go with an SA just because of, so there's a lot of pros and cons to each of them. But I think on the SA side, investors have a little bit more kind of anonymity. So it can help. But I mean, really going between an SARL and an SA, it just depends on what you're looking for, what you plan your company to be. Yeah.
Okay, good. Now, thank you. So I guess summary for me, I think the takeaway is, ask help, get professional help. There are people in the ecosystem who can help, who've done this a few times. You don't have to reinvent the wheel. Thank you. That makes sense. So again, there are a lot of moving blocks from, you're setting up the company, you're going through a few things. Were there people who helped you, who really helped you to go along, and when you had self-doubts, to saying, the advisors, what were the roles of the mentors, what helped?
So so in terms of coaching support, we had a lot of help from, and we still have help from Simon Johnson, who's at EPFL Innovation Park. He has some specialties in renewable energy, renewables in general, but he's like the drone guy essentially at EPFL. So he's been absolutely fantastic. Eric Plant, also from the ARC Clean Tech Alps, who we are in contact with on a weekly basis, is fantastic. Just for planning, taking those next steps, and really kind of helping keep us on track to the point where we are now. And then also Daniel Brandenberger, we met him through Climate Kick, and he has a lot of experience with like engineering and building stuff, and he has a lot of experience in like the Asian market. So he's really helped on the essentially the engineering technology side of stuff, the scaling, what we should be aware about if we were to go to another country like Asia, what are like the rules and regulations. We actually recently purchased equipment from a company he recommended, I think in China, and he knew people who would go and see it. So there's the coaching and the support system in Switzerland is really, really great for this. And they can really help and direct you to the places that you need to go. I think we also have a lot of family support as well, and friend support. So my husband works in a startup. Almost all my friends work in a startup. So if there's some days where if you're really frustrated and you just need to like not vent, but just kind of like people understand why maybe you're a little bit like anxious or stressed or tired, that's also really good, is to have that that support outside of work, that you can go and have a beer with somebody and just be like, today was just that week, so.
Awesome. So I have the other questions, but what you said triggered a little bit more. So you start the core 3 team, I reckon, till you got financing, and you're talking with all these mentors to help you. And how did you feel during the whole process? Did you say, like, I don't know some of this, I'm scared, how am I going to figure it out? Or do you say, look, I think I can manage it? How did you go about figuring those?
It's a learning curve. I think for all of us, it was a learning curve, and it still is a learning curve, because this is our the first time for all of us that we've done a startup, at least that has got to this point. Chris and Bardia had done startups in the UK and Iran before they had come here. So they had a little bit of experience, but on the scaling side and aiming towards commercialization of the technology, yeah, it's definitely still a learning curve, but it's fun. It's entirely different than academia, and I think we really just take all the challenges in those days with stride and just like learn the most that we can from it. And if we're really stuck, we just reach out to our support systems and say like, hey guys, I don't know how to deal with this. Do you guys have any advice? Or this is a problem that we're going to see in the future. Do you have something that we can prepare us for it, at least so that when it pops up, we have an idea of what to do. So yeah, it's, if you like challenges and if you like it, like having different days every day, it's not the same task, then this is definitely something to look into, is do a startup.
Yeah. Awesome. So then I go back to my list again, right? Any regrets? I mean, not more to saying, we shouldn't have done that, not that. If you could rewind time and you could do certain things differently, what would you have done different?
I don't know if I would do anything differently at the moment. Nothing at this point has like stuck out that was like oh shoot, maybe we should have done it this way. Yeah, I think right now there's nothing that stands out. I would have been, I mean, it would have been nice to know all the chemistry right off the bat instead of spending time to do the research, but that you can't kind of fix, unfortunately.
That's a brilliant problem to have, and I think that kind of gives your your IP to saying if it was easy to figure it out, now you figured it out. So that's awesome. There was a question from Roland and a few questions there, and kind of relates to some of the questions I have. So I'll go to Roland's question first. Was there ever a moment you wanted to stop what you were doing and give up? Yeah, first part.
No, not give up the startup. I have had days where I've just been like so tired that I just want to close my laptop and go to sleep. But I've never had a moment yet where I'm like, I'm done. I quit.
Okay, so the second part doesn't matter, because if so, what happened to pull you back and keep going? But the other part was, how do you do work-life balance? Do you shut down, or is it 24/7? How do you have a system to manage?
Yeah. So I'm really bad at this. When I go home, I do not look at my work, like my computer. And this is actually, I used to play video games a lot more frequently than I did. But the problem is I found that before I would start playing something, I'd check my emails, or after I check my emails, or I check my emails before bed. So I really try when I get home to not, unless it's like talking to my family on like on my phone or something like that, like to not look at anything work related. But this still is hard because it's always in the back of your head. If we're trying to figure out a problem, or if I'm trying to think of just something to make something more optimized, or if there was something particular that happened in the day that I just need to wrap my head around, I always catch myself thinking about it. But I also, to stop that, I make sure that I always try and set some time for myself aside to do something that I really like. So for example, I really like running. So on the weekends, I try and get all my long runs in, because then I can just shut my mind off. During the week, try and get some exercise in, either at the gym or go for a run. And then always try and make time for friends and family. So
awesome. That's the challenge. I mean, I don't think anybody has figured it out, but I'm glad you have systems in place to avoid burnout. There's a few questions there. I think that'll address the next two I have. So what's next? What's your immediate next plans, future plans for DePoly? What's the goal for the next couple of years? What do you guys want to do?
So we built a demonstrator plant at this central waste management company in Valet. So right now we're going through the commissioning phase of it. So our immediate first priority is getting this up and running. And then we have some orders to meet for some companies to test the TPA to convert it back to PET plastic. so that industry can start establishing that, yes, our process is what we say it is. It's not just, mirrors and smoke. So that's kind of our first priority, is to get those samples out, to finish the commissioning. And then once that's done, we're going to be developing the design and blueprints for the commercial plant, and for our continuous reactor, because right now we're batch, so we want to switch to continuous. So we'll work on that, and then simultaneously we'll be starting a fundraising round again. So this will be our seed. And then depending on what the cost for commercial plant will be, this will be kind of what we raise for our next financing round.
Awesome. So I'll go back to the questions, open questions. So one was about IP. So the IP was owned by EPFL, and you licensed the IP from EPFL. So that was the answer. You, for the record, Sam nodded. Yes.
Yes.
So what other question was, I know this was a process chemistry question, but I understand that your process works on room temperature and that's a major advantage, but does it also cost less than the other methods, apart from fuel saving that you said it was 66%?
At the moment, so we've based all of our financials off of our lab scale, and so this will be confirmed with our demonstrator plant also, which is what the commissioning and finishing that will help us do. But because we operate at room temperature, we actually save quite a bit of money. And so the plan for this is to essentially, when we sell the TPA and EG, is we sell it at market price without a premium, because a lot of companies have said that, yes, they want to go sustainable, but they don't want to pay the sustainable price. So this is also what we're trying to solve at the same time. And yeah, so that's kind of the goal, is to be as cost effective as possible. We're also trying to look at different ways around things like distillation, because that is a method that does cost, it is energy intensive to recover solvent. So we're looking at more greener, low energy methods for this as well. And yeah, so these are kind of the ideas of what we're trying to design for the commercial plant, is for it to be as cost effective as possible. Ideally, if we could hook up solar panels even, just to mitigate the price, then that would work as well. It'll just depend on when we build it, how expensive it is to have that system integrated into the plant.
Awesome. So I think you answered the question, but just to make sure I'm not saying the wrong thing, what's the final product after the process? Granules, sheets, something else?
So after the chemical reaction, it's a powder and a liquid. The powder and liquid then get sold to industry, and then they can turn it into like granules, sheets, fibers. It depends on who we sell it to, essentially.
Awesome. And there is a question from an anonymous attendee. What was the uniqueness in your business plan you think that made you stand out from others in the competition?
So I think the cost saving of it all is the biggest thing. The fact that it's at room temperature, and the fact that there hasn't been anybody who does it at room temperature for everything yet. Some people are very limited on the selection of PET plastic, for example, or like it's either bottles or it's fibers. Some people can't do both, and some people can't do it in the presence of other plastics. So I think that really sets us apart. So our USPs are basically the energy savings, the ability to have to not have to wash, sort, or screen. And the feedstock options for us are extremely wide. We don't have to be super picky on where we take it from.
Awesome. So there's no other live questions, so I've got a few more. Did anybody tell you this will not work?
Yes. Yeah. Yeah.
How did you deal with it?
I mean, people are allowed to have wrong opinions, but yeah. No, there's like any process that's going to come in to try and change the world or to change a viewpoint. There's always people who want to stick to the old-fashioned methods. And I understand this. Incineration is good for what it does. Mechanical recycling is good for what it does. But on a big picture, these have to change. And there's going to be laws that come out that are going to make it change. So why not just have the solution in place so that it's not a problem in the future. So yeah, I mean, the people who say no, it's not going to work, I like to have a conversation with them to see where they are, because they might have insights that I haven't thought of before. But in general, I mean, it's going to work. To me, it's a no-brainer. So I'm probably biased for that though.
So now that leads me to more on, so obviously, this will never work, will always be there, and now that's not going to change. But who said it'll work, and who were your first believers to saying, that's interesting, let's give it a go?
So, well, I mean, the team and our professor and family, I mean, they were the first to know that it worked. So they were the first that had said, like, go for it. In terms of companies, I can't really go into names, but there's a couple guys that we spoke to at the very start that saw it, and basically were like, you guys need to scale up as fast as possible. This needs to get to the market as fast as possible. And we still have the same kind of support from companies that come in and see this as well. And the coaches were, I think once the coaches knew that we were serious and that we had the plan in place, it was less convincing them about the chemistry and more convincing them about the team.
Okay, awesome. Now, so that leads to say, related question was that validation. When you reached out to those two industry folks, without naming them, how did you reach out to them? What did you do to find, okay, here's a list of people I'm going to check with. How did you know them? Were your contacts, or how did you know who to contact, and how did you do it?
So we were introduced through Eric Plum and the network through Venture and Climate Kick were the ones that put us in contact with more of the bigger companies. The two kind of initial guys that we spoke to, we just kind of cold emailed essentially, and cold called. Even though I didn't speak any Swiss German, they were able to, or German, I guess, or whatever. I can't remember if it's which headquarters I phoned them at. Anyways, yeah, they thankfully were able to understand the questions and were able to come down and see. So yeah, it's cold emailing and cold calling does work sometimes.
Good, awesome. That's the questions I had, and I think we both speak pretty fast, and I think we are out of questions.
Maybe I have a question. Have you ever had like weird comments when you were raising money because you were a woman?
No, actually, the ecosystem here is super fantastic for that. I've never had an issue with being like a female entrepreneur. I've spoke to other female entrepreneurs, and so far there seems to be somewhat of an agreement that Switzerland's good for that. Though sometimes you can tell you're definitely in a male dominated industry when, so the plant that we work at has more male bathrooms than female bathrooms. And I know another startup, when I spoke to her, she had said that when she worked in a plant as well, it was the same thing where there was like not really any female washrooms, for example, because it's the industry that you're in is more male dominated, so it has to switch. But yeah, so far, no issues.
Okay, well, that's good to hear.
So, what's your major learning over, so how long has DePoly been from incorporation to now? You're 2-3 years old?
From incorporation, like a year and a half. From the start of the project, about 3 years now.
3 years, okay. So looking back, if you have to look and saying these are the major insights or major learning curves I'm grateful or I've learned, is there anything that pops up to saying that I learned because of this process? Didn't mean to.
That's difficult. Yeah, that's a difficult one to answer. Yeah, I mean, I think the whole process. So I guess generalization of it all. I definitely think that I got a lot more confidence when talking to people about the project and the business plan and writing. I know when I had first submitted it to Venture, I was talking to my husband and had said like, oh, we're not going to win this. And he was just like, why? So I really started looking a lot more positively at things as the whole thing progressed and seeing exactly what you can do, because sometimes you kind of have a mentality of, oh, I'm in academia, so I know just academia things. but you'd be surprised just how fast you can learn and how you can adapt to situations. So that was a huge learning, is that, yeah, you can be more confident, you can do those changes, you can take those steps, and you will stumble and you will fall. I have not had a perfect track record when it comes to being a CEO, in terms of, starting a company, because it's a learning curve. But I mean, there has been no, yeah, you pick yourself up and you dust yourself off and you say, yeah, okay, I learned from that. Next time when we do this, we do it this way instead. And yeah.
Awesome. Amazing to hear. One last one on this. So have you figured out your sales strategy yet, or is it still right now you're looking at demo plant, get that going, we figure those results, and then figure out sales, how go to market is, or are you working on it now?
No, we're working on it now. But to get to that step, we have to give the product out so that people can test it. And so that will be a huge, for us, when we go towards marketing and sales, when we have validation from, some of the big pet resin makers, and we can say, this person gave us this piece of paper that says our stuff is better than whatever the other sample was, then that'll be great for us. And it'll also give the industry more confidence in us as well. So it's all sort of tied into itself. Yeah.
Awesome. No, thank you. One of the questions from Anirudh was, he was deep, he's from India as well, and he was deeply interested on, look, plastic is a big problem in developing countries. Are you looking at scaling it to India and Africa and Southeast Asia? And what's your scale up plans? When do you realistically see? Is it the next 5 years? More to get more insights of where you are heading towards that.
Yeah, so we definitely, going into Asia, Southeast Asia, India, that whole area is a priority for us. It's one of the areas where we have dumped a lot of plastic, and recycling systems maybe aren't fully established there. So it is a leaching point in terms of where plastic can enter the ocean. Also, China deals with, like market-wise, they're like 70% of all users of PET plastic and producers of PTA, just because they've got such a large supply and demand that they need there. So yeah, getting into Asia and Southeast Asia is a priority for us. It probably would be around 2025 or so that I'm expecting we'll make the first steps there, because first we have to make the commercial plant here, get that blueprint established to build, and then go in. And then the goal would be entering, so it will be country dependent, because I mean, it's not all one system. So we will have to tailor our strategy. But for example, if we go into Southeast Asia, in the countries that don't have a recycling system, one of the things that we would like to do is pay people, like the communities, to collect the plastic for us. And then that can work as essentially a source of income for people. Right now, PET plastic is a commodity. A lot of people in these poor regions already do collect the plastic, but either they just throw it out or they try and give it to somebody who can give the money for it. But we want to, help those communities clean it up, maybe get some money for families, grow the community, support the community. So that's what we would really, really like to do.
Awesome. I'm by definition impatient. So for that, is it a question of money, or is it a question of processes that you want? I.e., let me rephrase the question. You said 2025. If you had more capital, more people, and you scale up a lot more faster, would you get there faster?
Yeah. Oh yeah, of course. Yeah. I mean, if somebody came by today and threw 100 million at us, we could probably start the commercial plant development now. Get the design start, just in the basic designs, the land where we're doing it. We could establish all of that now, and even just start getting the not even the upstream stuff, but the downstream processing. So like the solvent recovery systems, even start getting those into place, so that, let's say, in a year we hit the ground running. And then once we have the blueprint, we would have the money to go directly to, let's say, India or wherever, and just say, okay, listen, we're building a 10,000 ton plant here. It's going to cost this much money. Here's the capital. Let's do it. Let's work with the government. Let's work with the communities. Yeah.
Okay, good. I'm not sure people with 100 million are listening, but if they are, ready to get the money. Now, I hope somebody is, and I really, really hope you get the capital to scale up. For me, it's also you don't, so I'm just having this, and I just read it. It says 100% recyclable, but it's still, I know that I'm going to chuck it, and I'm not sure if somebody's going to recycle it. One of the pet peeves was I religiously split, paper, plastic in all the 6, 7 containers, and I used to put in different boxes. And was walking the dog, and I saw the guy collected and saying he took everything and put it in the same thing. I'm like, man, I just spent 2 hours separating it. Why are you putting it everything? Oh, look, everything goes to the same thing, but you just want to train people so that you know how to do it when the systems are in place. That was the biggest slap in my face I ever got. So we all assume that recycle is going to go where it's intended to, and
Nope.
recycling happens. I spent major of time in Australia, and all the glass bottles were broken down to powder, and there was this big warehouse with close to about 600 tons of broken glass, but they didn't have anywhere to recycle it and make anything else with it, right? And so that process is kind of opaque for end users. So even though if I'm green conscious, I do want to do the right thing, the next steps doesn't seem to be, because of all the other issues you highlighted on what happens next. So personally, I'm looking forward to it, and I hope you fix more of. Wish you the best. And if any, one last thing, which was a plug that I wanted to, like, almost forgot. I know that you're hiring. We have a lot of good folks at CERN, especially fellows who come spend a couple of years and then finish up at CERN and leave. Not so much on your process chemistry, but I might be wrong. We do have an alumni job portal. Send me the links, and I'm happy to post it, and have folks interested to join a startup, and join startups around here. So that was the plug. I almost forgot because I didn't write it down. But
maybe just a final question before we, do you have any tips, like let's say the top 3 tips you would give to scientists who are thinking about starting their own company?
Yeah, so first, depending on what the process is and what you're doing, get the chemistry down, because when you go through like a due diligence, particularly with the IP, it's good to have all that kind of sorted, or at least have the idea of how you're going to deal with it, so that when they ask questions, even if you start these conversations before, that you know what's going to happen. So have that sorted out. Make sure that you apply to as many non-dilutive funding options as possible, like VentureKick, Venture Lab offers a lot of courses that you can take, even just the basics, like how to do a pitch, how to approach customers, how to have those conversations with customers. So take advantage of everything that you can in your local community, because it's really, really helpful, and you will meet people there, either that are the same stage as you, or like the next step up that you can kind of talk to and get some ideas from, and then always ask for help. If you're stuck, don't hesitate to reach out to like coaches, or if anybody out there wants to just reach out to me, you're more than welcome to.